On this video, we're going to work some problems from our chapter on finding inverses and composition of functions. So here's our function. F of x is negative square root of 3 minus x. We have a restricted domain that x is less than or equal to 3. We're going to graph that first, then we're going to find its inverse, and then we're going to graph its inverse on the same axes. So to graph this, it might help our cause to factor that negative out, still inside the radical, but out of the 3 minus x. So now we can see that we have a double reflection and a translation 3 in the x direction. So a standard square root of x would go up and to the right. The negative outside the radical would flip that in the x-axis, and then the negative on the inside is going to flip it in the y. So we're going to go down and to the left, and then we're going to move it so that it starts at 3. So we're going to get something that looks like this. There's our function y equals f of x. Now we're going to find its inverse. So we're going to switch the x and the y and then try to solve for the new y. So we can, it doesn't matter if we multiply the negative or not, we're going to have to square both sides at some point to get rid of that radical, and that's going to at the same time get rid of that negative sign. So we're going to get x squared is 3 minus y. So we can subtract that 3 over, and then in turn multiply through by the negative 1 and get negative x squared plus 3. So this is what we are calling our inverse function. Now we can either from the graph or algebraically reason about what is our restricted domain. So we can see that the y values in the original are always going to be negative because the square root is a principal square root. So this negative means that y would always be less than or equal to 0. So our restricted domain is going to be x less than or equal to 0. So I'm going to graph this in a different color. I'm going to put it in red here. So we are going to have a parabola that opens down and has has vertex at 0, 3, and we're going to have the left half of that parabola. So hopefully we can see that it's a reflection in the line y equals x, as all inverses are. Okay, let's try another one. I'm going to slide this up. So our original function is going to be a parabola that opens down and is going to have vertex at negative 2, 0. So we're going to go 1, 2. It's a parabola that opens down, and we're only going to keep that part of it that is left of negative 2. So we're talking about something that's going to look like that. There's our y equals f of x. We're going to switch our x and y's and then solve for y. So we'll multiply that negative x to the other side, and then square root both sides. Remember, we want all possible square roots, so at this moment we're not sure if it's going to be the positive or the negative square root, and then we're going to subtract that 2 to the other side, and we need to decide, is it going to be a positive or negative? So since our x values were less than or equal to negative 2, when we switch our x's and y's, we want the y's to be less than negative 2. So that means we're going to need that to be a minus. So our inverse is going to be negative 2 minus the square root of negative x. Now that's a bit of a challenge to graph. We are going to know that it's going to be the standard square root function looks like that. The negative on the outside will reflect it in the x, and the negative on the inside is going to reflect it in the y, and this negative 2 is going to translate that down 2. So we're going to go down 2, and then we want I'm going to change colors here again and make it red again. So here is going to be our inverse function, the graph of our inverse function, and we can see that's going to be a reflection in the line y equals x. Okay? Changing gears a little bit. Now we're given a function f and a function g, and we're going to find f composed with g, which means the same thing as f of g of x. So we're going to take f of then the x squared plus 2. That means we're going to plug in the x squared plus 2 into the f function in place of the x. So that's going to look something like that. If we distribute that negative sign, we're going to get a 3 minus x squared minus 2. So that is going to be a 1 minus x squared. Now, that's our, that's f of g of x. So that is our composed function, the composition of f and g. Now, to get its domain, I bumped the thing. So we know that what's inside that radical, gotta bring my pen back up. What's inside that radical has to be greater than or equal to 0 because a square root's not defined for negatives. We're going to factor that as 1 minus x, 1 plus x, and we want to know what's that going to give us on a number line. So that will be equal to 0 at negative 1 and 1. And if we test that, if we plug in something like a negative 2, 1 minus negative 2 is positive, 1 plus negative 2 is negative, positive times negative is not going to be greater than or equal to 0, so we do not get anything to the left of negative 1. Plugging in something like 0 gives us 1 minus 0 is a positive, 1 plus 0 is also positive, so these are going to be in the domain. And if we plug in 2, we're going to get a negative and a positive. That's not in the domain. So our domain is going to be x is in between 1 and negative 1, including the endpoints. Let's try g composed with f. So this is going to be g of f of x. That means we're going to take g of, and the f of x was that square root of 3 minus x. So that's going to be the square root of 3 minus x squared plus 2. So that's going to look like 3 minus x plus 2, which is going to be 5 minus x. Now at first glance, it may look like that has no domain issues and that the domain would be all real numbers, but remember it's got to first, a number's got to first go into f and be defined there. And to be defined in f means that 3 minus x must be greater than or equal to 0. So that means that x must be less than or equal to 3. And that is our domain for g of f of x. Here's another one. Now we're going to find f of g of x again. So we're going to take f of the square root of x minus 9. So that means we're going to take the square root of x minus 9 squared plus 5. That's going to look like x minus 9 plus 5, which may look like it has domain all real numbers, but we know better. We know that this has to be defined when you first plug it into g, and g's domain says that x minus 9 must be greater than or equal to 0, so that makes the domain of f of g of x, x greater than or equal to 9. G of f of x means we're going to plug in x squared plus 5 into our g function, so we're going to get x squared plus 5 minus 9, and that's going to be the square root of x squared minus 4. There's our g of f of x, and its domain means that what's inside that radical must be greater than or equal to 0. Because it's squared, we're going to have to factor that and analyze a number line. And so we can see that at negative 2 and 2 we get 0. If I plug in -3, we get a negative times a negative is positive. 0 would be a negative times a positive, which is not greater than or equal to 0. And 3 would make them both positive, which would be positive. And so we're going to get for our domain x less than or equal to -2 or x greater than or equal to positive 2. And that must be written in two separate pieces. All right, let's see if we can first find the inverse of f of x equals 4x cubed minus 1. So we're thinking of that as y equals 4x cubed minus 1. We will switch the x and the y's, and then we're going to solve for the y. The y cubed is going to look like x plus 1 over 4 is y cubed, and we'll cube root that whole thing to get that y, which we're going to call f inverse of x, is going to be that cube root of x plus 1 all over 4. Then to verify their inverses, we're going to show that f of f inverse of x is x, and also that f inverse of f of x is going to equal x. So f of f inverse means we're going to take f of that cube root of x plus 1 over 4, and that means we're going to, let's see, that will be 4 times the cube root of x plus 1 over 4 cubed minus 1. The cube root and the cube will cancel. We'll get 4 times x plus 1 over 4 minus 1. The 4's will cancel. We'll get x plus 1 minus 1. And so we have done that part of it. Then we're going to also take f inverse of f of x, which is going to look like the cube root of, and then in place of that x, we're going to put in 4x cubed minus 1. We're going to add 1 and divide by 4. So that's going to be, let's see, inside that cube root, the 1's will kill each other off. So we're going to get the cube root of 4x cubed over 4. The 4's will kill each other off next, and we're going to get the cube root of x cubed, and that is our x, and we have verified that they are inverses. Now we're going to do some arithmetic here with complex numbers. So squaring out our 3 plus 2y, we're going to get the first one squared twice the product, so that's 6y times 2 is 12i, plus the second one squared is going to be 4i squared. We'll come back to that. We're going to distribute and get a minus 8i and a minus 20i squared. Now let's see, we know I squared is -1, so we're going to get, this is going to be a -4, and that's going to be a plus 20. So we're going to have 9 minus 4 is 5. 5 plus 20 is 25. And 12i minus 8i is 4i. And that's going to be our answer. To do the division, we're going to multiply top and bottom by the conjugate. That is, change the sign of the imaginary part. So distributing this, we're going to get 3 times 2 is 6, 3 times 3i is 9i, I times 2 is 2i, and I times 3i is 3i squared. On the bottom, we'll get the difference of 2 squares, 4 minus 9i squared. So the I squared is -1, making that -3, plus 6 is a positive 3, 9i plus 2i is 11i, and minus the 9i squared makes that a plus 9. That becomes 13. We'll split that apart so it looks like a plus bi, where the a is the fraction 3/13 and the b is the fraction 11/13. Okay, some powers of I. So 2i is just 2i. I squared is -1, so that's a -3. I cubed is a -I times the -4 makes that plus 4i. 5 over I to the 7th is our 5i to the -7. We're going to divide 7 by 4 and take the remainder. That's going to be I to the 3rd. I to the 3rd is I squared times I, which is a -I. We're going to multiply top and bottom by the conjugate of the denominator. That will take us to 5i and a -I squared, which is going to be a negative of -1, which will be +1. And so we end up with 5i. I to the 73rd, we're going to divide 73 by 4, and 4 goes into 73. Let's see, 4 times 18 is 72, so our remainder is 1, so that's going to be just I to the 1st. Okay, looks like we got -3 is the only real number part, so we're going to get -3, 2i, there's 6i, 11i, and that makes 12i, a total of 12i, and so there's our answer. Then our favorite problem, we haven't done this in a while, so we're going to take f of x plus h, that's going to be 3 times x plus h minus x plus h squared minus f of x is going to be a minus, and here's our f of x, all over h. So distributing the 3 makes that 3x plus 3h. We're going to get a minus, first one squared, twice the product, plus the second one squared. We're going to get a minus 3x and a plus x squared all over h. So that's going to be a 3x plus 3h minus x squared minus 2xh minus h squared minus 3x plus x squared all over h. If we did this right, everything that doesn't have an h should cancel. So it looks like 3x and a -3x are going to cancel. Negative x squared and a positive x squared are going to cancel. And I think everything else has h's. So we're going to get 3h minus 2xh minus h squared all over h. We'll factor out an h, leaving 3 minus 2x minus h all over h. Those will cancel, and our final answer is 3 minus 2x minus h. All right, I think that's all we got. Very good.